Assalamu alaikum. Hello, everyone. Hope you're well, and thank you for joining the second series of the Learning Hub. My name is Zina Al-Atasi. I'm the Head of Innovation at Oman Arab Bank. Over the next few months, we'll be running various workshops that are focused on promoting innovative thinking, enhancing your skill sets, and hopefully supporting you with your career journeys. These workshops will be announced via our social media pages and on our website. You can register for as many workshops as you like, and they're open to everyone. Today, we're excited to be joined by Ms. Anfal Alyousufi from PhazeRO, who will talk to us about how we can build recommendation engines using Ngrams. If you have any questions during the presentation, please send them in the chat window, and Anfal will address them at the end of the session. Otherwise, you'll have the opportunity to ask them live at the end of the session. Anfal, over to you.
Hello, everyone. So I am Anfal Alyousufi, a data scientist at PhazeRO. My topic today would be about advertisement recommendation using Ngrams. So many of us would have you ever wondered why so much brands would spend so much money in order to be heard on TV commercials, newspaper, or even on social media these days? So what makes someone trust a particular brand while shopping? The whole idea of being able to do all that, or to have the trust between the user and the brand, that is called the power of advertising. So what exactly is advertisement? Advertising. Advertisements are like messages that is being paid by brands and entities and able to reach to you and influence you to make a decision based on a product pitch. So everywhere you look, there's advertisement telling you about a product or even a service. And agencies who conceptualize and package these advertisements for brands have teams teams who would copy editors, visualizers, brand managers, researchers, creative heads, and designers. So that is the whole thing when it comes to advertisements. Talking more about advertisements, we do have different types of advertisements. My main goal in here would be the online advertising, which is also known as a digital advertising. So nowadays, digital advertising is a primarily revenue when it comes to driving on the internet. So we have various different types of online advertising. We have the Google AdWords. So what exactly Google would do is they would allow companies in order to bid on the placement of an ad on Google search. So like a company, let's say you are searching, a company with an insurance company would be on Google Ad, but how exactly it really works is that when a user would search a query for insurance products, those insurance companies or insurance company advertisements would come up. So that is how exactly it really, that is one of the ways how it really works. So the businesses would be paying Google if an ad was being clicked on. And this specific thing has a term called cost per click basis. And then we also do have Google AdSense, where it would allow companies to host ads on their websites from Google to generate revenue for the site. So in here, through its algorithm, AdSense Google would match the ads to various websites that is related to the content that they're trying to search. So that companies would be able to reach a larger audience through a Google placement of advertisements. Also, there is, I believe it is very, very popular nowadays when it comes to online advertisement, which is a LinkedIn advertising. So what exactly it does is that companies would be able to create business page and post content, videos, products, offering for their page in a way to reaching millions of users. So companies can also place ads on LinkedIn, like other companies would be able to place ads on LinkedIn to help reach a targeted audience. It could also be to a particular demographic area. So as we can see in here, that ads could be generated to a particular number of people, particular number of users. Then we also do have mobile advertising and cell phones. When it comes to mobile advertising and cell phone ads, it is one of the current trends when it comes to mobile advertising, which involves major use of social media such as Twitter, Instagram, Facebook. So these would help online advertising increase and gain importance in the methods of reaching new customers. We also do have other advertising that I'm not going to go in depth about, which is we have print advertising, we have outdoor advertising, and we have something known as public service advertising. And this specific one is a more of an education to a user rather than like selling a product or a service. Then going in depth into why do a user or why do we really get specific ads? So every day we are bombarded with different ads from salespeople, even friends trying to persuade you and trying to encourage you to watch like a specific show on Netflix, or even try out a new diet. All these things are more into like advertising. They're trying to like get you into doing something. And it could be like you could be convinced and you could not be really convinced of on doing that. And there are dozens of factors that can cause you to agree or disagree with the message that is being sent to you. So in order to get the specific ads, we do have like ads maybe based on the content that a user is searching. Let's say you did view a specific video online, and among other factors that they will like turn it into their algorithm and be able to output some data. Like let's say this user like this one, they would probably like the other video. And other factors could be like the age, the range, the gender, and other activity on Google services like Google Ads would help them get you a specific ad. Also, there is a specific thing which I found it interesting, which is like the companies or organizations are trying to strive and improve the user's ads experience. And by doing that, they're trying to implement policies into their ads to get more relevant ads. Like, yes, we do have yes, you do get specific ads to the stuff that you do like, but there are sometimes you are getting, let's say, an inappropriate ad or an ad that is not into you don't really like, it's not something you're enjoying watching, or it's not something you really are into. So in order to do that, companies what they're trying to implement are policies to help control the ads that the users are getting. So in order to do that, they do have something known as submitting a feedback, where a user would be able to submit a feedback if they thought that a specific ad is an inappropriate, or they did not like the specific ad with a message with it. Like, let's say, why don't I like that specific ad? So that is how it's helping companies to get more ads into what the user really wants. So when it comes to the whole system of a recommendation system, we have two main things. They are built into prediction of users. We do have something known as a collaborative filtering, like the whole idea of a recommendation. We do have collaborative filtering and a content-based filtering. So these are the two types of recommendation systems, depending on the goals of the audience and the platform that you're trying to recommend. So when trying to have different recommendation system, the number one is a collaborative filtering. So collaborative filtering, it is primarily that makes recommendation based on the inputs or actions from the other people rather than the user themselves. Let's say user, like as you can see in the image, the user on the right did like buy these specific things, and the user on the left did buy these specific two dishes. They would assume that the soda would be like, they would assume the user on the left would like the soda, so they would recommend them. So it is more into what other people are liking, and then they would recommend me based on that. So variation on these types of recommendation would be based on user similarity and association. And there's other factors, but I thought these two would be the main two to like discuss in this talk. So when it comes to user similarity, so this strategy involves in creating groups by comparing users and activities and providing recommendations that are popular among other members of the group. So it is very useful on sites with strong but versatile audience to quickly be able to provide recommendation for users on which little information are available. So this would help when we do have like less number of information of a user. So that is how user similarity would be used. And we do have associations. So association are more into specific types, which as you can see in the image, user who looked at X would also look at Y. And implementing this type of recommendation system is a matter of looking at purchasing sequences or purchasing groups, and also showing similar content. So this strategy is very useful when capturing recommendations related to naturally complementary content as well at a certain point in the life of a user. So that is how collaborative filtering is. And then we do have the other recommendation system that I mentioned earlier, which is the content-based recommendation system. So content-based system, it is based on the user's purchase or consumption of a history. So it is more of a user that what user did like, what user did purchase, or what user did watch, like when it comes to shows, rather than like other people. So generally, it became more accurate the more inputs we do have. So the more inputs the user takes, the more accurate the algorithm could be. So more specific types on content-based recommendation system would be content similarity. As the most basic type of content-based recommendation system, this strategy would involve into recommending content that is closed based on the metadata that we do have. So this approach would make more sense for catalogs with a lot of rich metadata, and which and where traffic is low compared to the number of products in the catalog. So that is how exactly content similarity really works. Then we do have something else which is known as the latent factor modeling. So latent factor modeling is like moving further from the content similarity. In here, the strategy is to inferring individuals' inherent interest by assuming that the previous choice would be like indicates of a certain taste or hobby. Let's say they like specific dish, they would assume that the other the dish that they are recommending would be of that taste. Or of that hobby, of that whatever. So this is done by using history of users' larger interaction, example, the movie they watched, the item they purchased, the food they consumed, and so on, in order to learn the test. So it is more of a learning or a training testing algorithm. Then we do have the topic modeling, which is a variant of a latent factor modeling that is mentioned earlier, whereby it is instead it is considering users' larger actions. One would infer interest by analyzing an unstructured text. So here is more of having an unstructured text and detecting particular topic of interest. So it is such more of a use of an article and so on. That is how topic modeling really is. And finally, we do have the popular content promotion, and this involves like highlighting the product's recommendation based on the product's of intrinsic features that the user did purchase earlier, such as like, let's say, based on the features of the item that they ordered, they got it before or ordered before, or even the price or popularity of the product. So that is how really content promotion really works. So this is often the case where the new content is the majority. Then now we would speak about, or we talk about the 6 steps in order to building a recommendation system. Let's say you are a company, you do want to build a recommendation system. How would you start? Step number 1 is you should understand the business. You should understand what the organization really is about. So once you do all that, once you have all that set, you would move further and try to get the data that you need. Go get the amount of data, and it will all be like, it will be a raw data. So once you do have that data, you would need to explore, clean it. So once it is explored and being cleaned, then you would need to do some prediction. Prediction would help you then visualize the data. So once you are predicted, you would have some graphs and tables, and then once you have the visualized data, visualized of the data that you had earlier, you would then iterate and deploy those models into your system. So that is how the recommendation system could work. Then going in depth when it comes to a recommendation system and how exactly it would really work, we need to understand the term text mining. So text mining, it is one of the deep learning that is already being used in some of the biggest and powerful recommendation systems in the world, such as Spotify, Netflix, and YouTube. So text mining would involve having a series of activities that is being performed in order to efficiently mine those information and have them into like specific and have the analysis of those information. So step number 1, let's say you do have this bunch of data you collected. Like step number 1, you need to go to understand the organization, and then As I mentioned earlier, you need to get the data. How would you get the data? First, there's something known as gathering. So gathering means we need to collect the data from different resources. Let's say you would get information from the websites, from emails, from even customer comments, document files. So first of all, you need to gather those data. So depending on and gathering would depend on the application that is being used. And this process can be completely automated or guided by the text miner, depending on what exactly you are trying to do in here. So once you have all the information, you would start doing the next step, which is the most important step, which is known as the pre-processing. So pre-processing is more it is more of a content identification and extraction of features. In here, we would need to do some cleaning up of data, which is known as text cleanup. Text cleanup would be removing of any unwanted information from the ads or from the pages that we do have. So once we're done with that, we do something known as tokenization. I will talk more about tokenization on my demo, but in here, tokenization meaning we would try to, like a computer would see a string of a character without, for example, paragraphs. So we'll just try to get the word that we need without spaces, without punctuation. We'll try to remove all that. That is what tokenization is. And then inside pre-processing, we also need to do something known as feature extraction, and which is also known as attribute selection. So in here, we'll try to get some in here we'll try to get the frequency of the words or text or information that we're trying to pre-process. And then these features would help us of a further pre-processing when it comes to pre-processing. So once we are done with cleaning up of the data and pre-processing, we would go to the next step, which is indexing. So indexing is more of a creating of index certain terms. This would be like location, numbers, and so on. So this would help so indexing is more of a quick access and easier to access and easier to be structured and pre-processed whenever needed. So once we are done with indexing, we will then go to mining, which is an algorithm. So this step, so once we have a properly pre-processed information or data, now it can be mined. For that, we'll apply different data exploration techniques to reveal new knowledge. So mining is more of an example that is identifying most commonly used words or terms and linking them into the dictionary and being able to identify the relationships between different types of terms. Once we are done with all that, the final step would be analyzing. So analysis is the mining steps would produce raw results. So once we do have the raw results, we need to be evaluated, visualized, into graphs, tables, and so on. And then finally could be interpreted with respect to these questions and what the text miner would want to investigate. So that is what exactly text mining would be when it comes to recommendation system. So my topic was more into ad recommendations using Ngrams. So what exactly grams is? So grams is a continuous sequences of tokens. Tokens could be words, characters, and so on. So in grams, we can have a 1 gram. 1 gram would be called a unigram. So if we have the sentence "fine, thank you," in here we have 3 tokens when it comes to word level. Fine is a token, thank is a token, you is a token. And a character level, we have every character or every letter is a token. So the letter F is a token, I is a token, N is a token, and as you move on, even a space is a token. And then we do have 2 grams. 2 grams is also known as a bigram. So if we have the same word, the same sentence earlier, fine, thank you, in here we would have 2 tokens. The word level token, we have fine, thank is a token, thank you is a token. And a character level, each 2 characters would be of a token because it is a 2 gram, it's also known as a bigram. Then we have a 3 gram token, which is also as a trigram. In here, the word fine, thank you, the word level would have a 1 token as a fine, thank you as a token, and as a character level, every 3 characters is of a token. So we would use, so why would, if anyone would think, why are we really using Ngrams? So Ngrams would help us get and overcome the bag of words and drawback that we're trying to get. It will help even get the misspelling and next word prediction and so on. But when it comes to the ad recommendation and my whole topic in here, so why did I think of using Ngrams rather than using any other things? So Ngrams analysis is more of a statistical method that advertisers can use to discover the most profitable keywords. So my goal is in here to have organizations be able to spend their dollars into the words that they would gain from. They would like gain the money, gain their dollars back. So rather than just using any random words, using Ngrams would help us target that, would help us be able to use specific words for specific advertisements. So in here, I do have a GitHub account for my demonstration, but I thought it would be easier if I just took specific steps and with the specific codes explaining my whole Python-based Ngram analysis script for an easy analysis. So step number 1 in here, I gathered some data. So I used in here, I targeted data from of videos available on YouTube. So I used YouTube API v3, and this helped me. This API was created by Google itself, and able to interact with YouTube as a piece of code specifically for programmers. So I thought that would be interesting for me to use it. So I did that. So how exactly I did? First of all, I imported some files. I imported pandas and other files. And then I gathered my data using the YouTube API, using my API key and the YouTube API. Then step number 2, step number 1 is for the importing of data. So my goal in here was, I thought it would be very useful if it was very simple and it would be very satisfying if I was able to collect data based on categories rather than just having like a bunch of data. I thought it would be interesting if, or even beneficial for me to have them into 6 categories. So I thought I would collect data based on these 6 categories as a travel, blogs, science, technology, food, manufacturing, history, art, and music. So I was able to do that. What I did is I gathered data for all the 6 categories. As you can see in here, an example for category number 1 for travel data. I gathered all the information, all the ads from travel YouTube videos or travel ads that is on YouTube. So I got around 1,700 data or ads from every category. So I did have 1,700 for all the 6 categories. So here's an example for category number 1. When it comes to science data, I did the same exact thing, got my results and had them all down. So I did the same exact thing for the 6 categories. So step number 3 was now I do have all the data for all the categories. Now I need to construct them. So in order to be able to construct them, you would need to gather all the titles, all the descriptions, the IDs and categories. And once you have all that, you need to transfer them to a CSV file. So in here, I constructed my data set. I had the final titles, final description, final IDs, as well as categories. And I transferred them to a CSV file called Anfal videos_data.csv file. So in my CSV file, I had the data looked like this. So this one is called raw data. So now I do have my raw data. I need to move further with the classification. So step number 4 was more of a test classification. In here, once I do have the raw data, now I need to import those data. So first of all, I imported some necessary libraries such as pandas and LLTK, and importing some word tokenized libraries and so on. So I did all that after importing my libraries. I loaded my data from the CSV file into pandas data frame. So once I did have that, I did have the title I printed out earlier, the description, and also the categories. And then I was able to remove an extra unnamed. So there's some columns that were unnamed. So I did that as this sentence you can see in here, the data allocation. I removed any column that was unnamed. So once we're done with all that, now we need to do the pre-processing, as you remember the picture earlier. So the pre-processing in here, meaning we need to do some cleaning of data and analyzing if we do have any missing description. And then, so in here, my step number one, I thought it would be good if I was able to print if I do have any missing values. Because if we do have any missing values, we need to fix that first, and then move further with our cleaning and text mining. So in here, I was able to print. I did print if we do have any missing values. I got the answer 0, and once I got the answer 0, I was able to move further with cleaning my my data. So step number one, I thought it would be good if I was able to change to a lowercase. So it is more of a practice to keep all the text in the same format. It is not really necessary, but it is a good practice to do that. So I did change all the characters to lowercase, and then I was able to remove the numbers. So removing numbers and punctuation would help. Sorry for that. Would help determine the correct class. So doing so, a numbers recommendation is a good thing when it comes to when we need to move further with tokenizing. So doing that, also we need to remove some extra white space because having white space would be problems when it comes to tokenizing. So once we're done with that, now we need to tokenize them into words. So tokenization into words, meaning we need to split a text string into a list of tokens. As you can see an example in here, the cat sat on the mat. When it comes to tokens, it is like every word is of a token. So that is exactly what tokenization means. Then after doing that, we need to remove the non-alphabetical tokens as well as filter stop words. Stop words are more of words like and, the, is, etc. The words that are not really important. So doing so would be it is important to be able to construct the sentences without those words, because it is not really of a use when it comes to doing more algorithms and more clean, more visual, more analysis. Then I did the lemmatization. Lemmatization is more of a referring a word to is more of converting word into its base meaning. Let's say the word rocks would be into a rock, better would be good. So moving it to its base meaning. And then finally, I would turn all the lists that I did have back to strings. So once I'm done with that, now we need to do the pre-processing. So in here, I thought it would be good if I was able to convert the labels into numerical forms, which is a machine readable form. So all the categories was changed to numbers rather than having, like, as you can remember earlier, we did have the word travel, science, data, and so on. So I moved them all to numbers because it is more of a machine readable. So once I'm done with that, next I needed to do some vectorizing of text features. So in here, I used scikit-learn library to vectorize my text features. So in here, I was able to calculate the frequency of each word that is inside and across multiple documents to identify how important those words are. So I was able to get the title features shape and the description features shapes, as you can see here. So these are more of the frequency of every of the words that is being used across multiple documents. Then step number 8, I did some analysis and feature exploration. So in here, I printed out the sample of each class I did have. So I did have 6 categories, as you can see. As I mentioned earlier, I had around 1,700 sample data for every category. So here I was able to print a graph for that for easy analysis. And then after doing that, I thought we need to print some keywords for easy analysis. So I did that based on a title features, as you can see in here. I printed out the most correlated unigrams and the most correlated bigrams. So I did for 5 words, as you can see here. it is like, as you can see, it would be like 10 keywords, but in real, it is more of a 5 keywords. So I did for unigram and bigram. So I did for 1 talking and 2 talking. And then I did the same thing for description features. So I did for the title and description. So once I had that for all the 6 categories, I then did some modeling and training of my data. So in here, I tried to define and analyze the data that I had earlier to support the machine learning model and store them into a database and in order to perform required operations on them. So I did the features for both the title and description, as you can see in here, and you will see more of a 1 to 3. So these, what exactly it means? It means I just need the columns from 1 to 3. Other than that, other columns would be more of a not a number, like NaN. So I'm just ignoring them for easy cleaning up or easy modeling. So once I'm done with that, I did print out some title, description of the videos. So after doing that, I thought it would be good if I was able to check my evaluation, my performance evaluation. So I did use 4 different classifiers. So when it comes to data analysis and data science, we need to test our data into different classifiers. So I did that within 4 different classifiers: naive based, SVM, AdaBoost, and LSTM. So in here, I was able to get the accuracy of these four classifiers. And I thought support, vector machine, and LSTM did give me the best accuracy. So after doing that, I printed out some confusion matrix. So confusion matrix is more of a summarizing the performance of the classifiers that we did. We did the algorithm classification that we trained earlier. So how exactly we would read a confusion matrix is that each row of the matrix represents an instant that is being predicted class, while each column would be of an actual class. So let's say when it comes to naive based, if we do have an art and music, and the prediction was art and music, it would print the number in the box, the brownish box, the light brown box. So that's how exactly it is doing. So based on that, I did print out the confusion matrix for all the 4 classifiers, and it was an easy read and easy understanding which one was causing an error when it comes to classification. And then finally, which is making a recommendation, I was able, the step number 11 was to see our recommender system. So in here came a part where we finally get to see our recommender system. As we know, when we input in here, I did input my unigram rather than bigrams. I thought it would be easier for my algorithm to read it. So as we know that on YouTube, we do have advertisement from a third-party website. So that's how So my goal in here was to be able to get those links back and output the URL links of advertisements related to a given keywords that from the unigram that we have. So I did the following. I was like in here, I wanted to just have a result for the travel. So which is category number 1. And these are the URLs that I came up with for just the travel. And we can do the same thing for all the six other categories. So for my summary, as we know that recommendation system can be an effective way to expose users to content that may not even otherwise be found, or which we can turn forward larger, we can even turn a larger business into increasing their sales, advertising revenue, or even user engagements. That is why we need a recommendation system. Why we need to understand how the concept of recommendation system really works in order to do all that. There are a few keys that we need to understand to be successful, such as recommendation system should be one of the main necessary point that we need to take into consideration. And if you would like to go through the code that I coded for more detailed code, please refer to my GitHub. The link, as you can see on the left. And finally, if you do have any questions, feel free to ask. Thank you.
Thank you so much, Anfal, for this very, very detailed presentation and taking us through the process step by step. I hope it has helped our participants to understand what they need to do to be able to build their own recommendation engines. We'll give the opportunity to our participants now to ask questions. If you have any questions, please just raise your hand or type it in the chat window. Of course, I just wanted to highlight that these sessions will be available on YouTube as well. There's a lot of information to take in, so you can always go back to our YouTube channel and just replay it, refresh some of the information that you have. Okay, any questions? Not for the time being. All right, Anfal, I want to thank you very much for such an insightful session. I think it'll be helpful perhaps in the future to invite you back again, maybe to talk us through some of the recommendation engines that you've built, and perhaps some of the do's and don'ts of building them as well, so that our participants can learn and experience it real time as well. But thank you very much for your time, and thank you once again to PhazeRO for supporting us with the Learning Hub platform. And we look forward to welcoming you back again, inshallah, in upcoming sessions and workshops. I'd also like to thank all our participants and innovators for joining our sessions. We have a number of sessions running this month. Please refer to our website for more details and to register. A lot of them are focused on innovation topics or on personal development. So we strongly recommend that you register and take the full benefit of these sessions. So thank you so much once again, Anfal. Thank you all for joining.
Thank you for
we look forward
having
to
me.
seeing you next time, inshallah. Thank you.